Bernard Tobin here at the Canadian Weed Science Society, joined now by Dr. Clarence Swanton from the University of Guelph. Clarence, how are you doing today?
I'm well, thanks. Thanks for chatting with me.
Clarence, you've just spent a little over 45 minutes talking about your career in weed science, 35 years, and some of the highlights of what we've learned over the years, and you've been at the forefront of much of this, and I just want to go through some of that and where we might go in the future. And just going back when you started and where some of the beginning here, is it really about understanding, I guess the start here, the impact of competition in weeds?
Right. We started to look at the whole plant level and trying to understand the timing for weed control and how that varied based on your management, based on the time of weed emergence. And so we began to realize that if we looked at weed competition, some of the things that we normally thought of that would influence this equation of light, water, nutrients just did not simply apply to our agriculture scenario. And so then the question why is that? What's so different about competition when we're looking at weeds and crops? And so that was kind of the beginning. Yeah. What I presented today was about how a plant can actually communicate, how a plant detects its neighbors, and how that detection and that communication can change how your crop plant grows and how it deals with stress now and in the future.
A couple of things come to mind. I mean, that critical weed-free period, that control period. And out of that comes what you talked about today, the psychology of fear when it comes to weeds.
Psychology of fear. Well, this is interesting because I use that term because in our experiments where we are just simply allowing a crop plant to communicate with a weed plant, we're also supplying the crop plant with plenty of water, plenty of light and nutrients, so it should be totally happy. What's fascinating is that despite all of that resource that's available to that plant, when it detects the presence of the weed, that detection changes everything in the crop plant.
And I mean, some of your more recent work also talked about, some groundbreaking work recently, is that ability to sense weed competition even underground.
Yeah, that's amazing. That just gives you an idea of how fast the plant changes. So as it's coming up as it's nearing the surface, it begins to read temperature and moisture and what's above the ground. And in this particular case, it was able to detect that there was green tissue from weeds. Now that has significant implications in the idea of planting green with our cover crops. These plants will detect that there's a green surface, and it will change how they allocate their shoot and root carbon.
Just going back to some of the other things you talked about, and with Christmas coming on, I thought it was interesting you used the term the ghost of competition past, because once that competition is there, it has an impact that follows that plant right through to yield.
Exactly. This is the other thing, we think about, one of the amazing things was that the changes that occurred in a crop plant at the seedling growth stage, despite the fact that you've got 95% of the growing season still ahead of that plant, the changes that occurred in that seedling and the impact of that changed the yield potential. That change was with that plant throughout its entire cycle. So that's what I'm referring to, the ghost of competition past. Even though you controlled your weeds later on, those weeds caused a change in the crop plant, and that change could still be seen throughout the entire life cycle of that plant.
Now, 35 years, you're still at it, and you've got new ideas. I want to talk about something that you shared with the group today, and that is that concentration of nitrate in plant roots and what we can learn and what we could probably see from some of your research in the future.
Well, I just gave a little hint of some of the stuff that we were, new stuff, because I wanted to bring everybody up to date where we're at. And this really has to do with nitrogen uptake. Now, we're looking at a soybean plant prior to nodulation. And to our surprise, we found that it might be possible that the presence of a weed changes the ability of a soybean plant to mobilize nitrogen. Never been seen or heard of in the biological world before. So our preliminary data points us in that direction. We're trying to understand what that means. We're doing it on soybeans now, and we will be doing it on corn. To see if that's a common response. I'm looking forward to talking about that in the future if we can show some real effect.
Final question for you, and it actually came from the floor here today. We've got all this understanding now of how plants talk and respond to weeds. And one person asked, is there a possibility that we could jam the signals of the weeds and enhance the plants? And you had an interesting answer to that.
Well, the answer to that is yes. We are aware that there are some opportunities to do that. Thimethoxam, which is a neonicotinoid seed treatment, was able to be very beneficial in helping a plant reduce the impact of that communication between a plant and a weed. That was really quite a novel discovery because it opens up the idea of seed treatments, thinking about seed treatments way beyond crop protection. We're now looking about how can we influence the stress tolerance by simply adding a little bit of chemistry onto the seed.
Hey, final thought, you talked about a little bit of plant breeding here and the potential from what you're learning to maybe breed more robust plants.
Right now, we talk about insect tolerance in plants, we talk about disease tolerance, but nobody talks about tolerance in terms of weed pressure. And the question that drives me is, would it be possible to actually think about breeding a plant that's able to tolerate a weed or maybe able to tolerate the presence of a cover crop better than our existing hybrids today? And so that's some of the potential outcomes from our study. I think that we're well on the road to maybe showing that could be a possibility, but I've yet to finish all that work, and hopefully I can do that.
Well, Clarence, we'll hang around long enough to see you get that done. Thank you for your time today.
Thank you very much.